Let me know once my screen is visible.
Yes, Saurabh.
Yeah, it's
Yes.
visible.
Okay. So this is what we did in the part one. This is more of a refresher for those who couldn't join yesterday. We first understand why RAG exists. We got a good understanding of how RAG actually works and why is it needed. Then we looked at the pipeline. It has load, split, embed, store, retrieve, and generate. Okay. From here, we did load. We did the splitting part. Okay, and validated those splitted chunks. Okay, so now we'll continue from there. All right. So first thing, to embed, we have discussed it now in multiple classes. I hope this is clear to everyone that if we say we are embedding our chunks, we just take each chunk of text and convert into a vector. And a vector that we are using is again a list of, for now, 384 dimensions or 384 numbers, right? But depending on which models are we using, it could vary. All right. Now using our embedding model, which is all mini ML6V2, we are going to run it locally on our system. If and you want to do it through an OpenAI, you have that option as well. It provides even more options for you and even more dimensions. Instead of 384, I think it's provides something around 1500 or something that we saw in the uh, I think last to last embedding class. Okay. And apart from that, there is one crucial thing. And again, as we discussed yesterday about interview questions, this is also something that will keep coming on interviews, right? You must use the same embedding model for indexing and querying. Okay. So suppose if you embed your document with model A or model X and then embed your questions with model V, the vectors live in different mathematical spaces, right? One model would be having its own learning and its own understanding. So the way it would understand and convert text into numbers would be different from what a different model would do. Okay. So you should use same embedding models for both when you're indexing it and when you're querying it. Okay. All right. So once embedding is done, next is to store it. Basically, once you have the vectors, you are going to store it in your DB, which we use ChromaDB. Okay. And each entry in the database has three things: the embedding vector, which we already saw. How does it create? Okay. From chunks perspective, the original text of the chunk. Okay. So that you can go back to that chunk whenever you find a similar semantic search. All right. And it's metadata, which is data about that data that we save so that querying can become faster. Okay. And all three are combined in the DB. All three travel together. Okay. Now, earlier we used client, right? We can use persist directory to save that database to disk. If you are just creating a new client, that remains or that lives only in your current script's memory. But if you use persist directory with ChromaDB, that is going to be saved as database in your disk, so that the next time you are going to run it, you can get the same embeddings already ready made. You don't have to recook it. Okay. Okay. Lastly, we'll go to retrieve. Now this is where the actual logic or calculations and for us the answering happens. Okay. A user types a question, we embed that question using the same embedding model. Now we get the vector for that question. We compare it against all the stored chunk vectors and find the ones that are the closest. And closest would mean the least distance or numerically least difference between two numbers. Okay. And we use cosine similarity to find that distance and find the closest one. And based on that, whichever are the nearest chunks, we retrieve those chunks. You can give a value of k for getting those chunks. So k equals to 2 means 2 nearest chunk, k equals to 3 means 3 nearest chunk. Okay. And we retrieve those k chunks. Okay. And then we take those chunks with your input that you have provided and send it to LLM for generation. Okay. This is the same thing that we discussed yesterday. This is again a refresher for those who couldn't join yesterday. All right. But anyways, if you'll see the recording for yesterday, you'll realize, in detail, you'll be able to see what we are talking about. Okay. Now, generating the answer. So the prompt sent to LLM system, answer based only on the context below. This context is the chunks that we have. Okay. And then we give the user query, whatever the query that user would have asked for. For an example, what is the refund policy? Okay. And as we discussed, you can have, hundreds of thousands of documents in your knowledge repository, out of which you have to search. LLM is never going to get all of that. The call that happens, it is only going to get the relevant chunks. That does two things. It is going to save a lot of infrastructure for you, and hence the cost. Okay. And we obviously want to reduce the cost. But when we are sending this system information with our user query, we are basically making sure that everything that is answered from the correct source and not its own internet knowledge, which might not be correct in our scenario. Okay. All right. So two simple RAG improvements, we'll see those as well. Multi-query retrieval. One query might miss relevant chunks if the wording doesn't match. So what we do is we ask the LLM to rephrase the user's question in different ways and search with all of them. So you'll get more results from our chunks, and you are going to combine all of those when you're querying your LLM actually. Okay. Next is metadata filtering. Because we have put the metadata, we have tried metadata filtering earlier as well, right? It's R where conditions like in RDBMS. Okay. With those, you are going to get the right chunks or relevant chunks. Okay. And again, that reduces some processing time as well, because you are first looking at just the say categories. If it's about food, travel, etc., etc., if you find those categories, you're only going to look into those chunks. There are different kind of categorization that you do, right? And based on that, you can filter with the metadata. So multi-query retrieval and metadata filtering are two things that can improve your RAG pipeline. All right. These are some of the questions which are usually asked. RAG, and why is it often better than fine tuning for private data? If you'll read more about fine tuning, right, we have done some fine tuning at our end once, and we are still, that's pretty much done. We are getting good results, etc., etc. But at the end of the day, if you fine tune a model, all right, you still need GPUs for inference. That is, the cost is very heavy. Okay. So first of all, you have to look, is the cost worth it, the results that you're getting against? Okay. And if that does, you feel that it is worth it, right? But there are new papers coming which says that after fine tuning, even after doing fine tuning is like you update the weights of a model, and those are for smaller open source models that you can actually update their weights, and so that they are trained on your specific data, right? And the answers would be much more relevant to yours, right? But in reality, with new papers which are coming, they say that the already provided LLMs, they are already doing very good, right? Uh, and fine tuning, even by updating weights multiple times, it still lags that kind of accuracy that people hoped for. Okay, so these are the reason when you compare it with fine tuning. And RAG, you are providing your own data, you are certain that the context would always remain same. Okay. What is chunk size and overlap we discussed, so I'm sure this already you know. And how do you decide what values to use? Simple. Too small, the context would be very small. LM will not be able to understand how to answer. Too big, the noise. Okay. What happens when retrieved chunks don't contain the answer? So the retrieved chunks, if they do not have the answer, what would happen? We are going to use a safety net, and we always use safety net. Basically, if your documents do not have that answer, you should not answer, right? That is why RAG is needed. You do not, we don't let model answer from its own knowledge, or don't let it hallucinate. Okay. All right. Any questions on these things? Embedding, store, retrieval, generating the answer, how to improve your RAG pipelines, and the common interview Q&A that happens. Okay. See, most of you did join yesterday, so I'm assuming your understanding would anyways be better, but still, whoever didn't join yesterday, if you have any questions on these, the topics that we just discussed, please feel free to ask. Okay. All right. If not, then let's move to the coding part. Okay. Let me share my screen again. and do let me know once my screen is visible.
Yes.
Okay, so yesterday we did this. Okay, again, just a quick refresher. This is the policies for, HR policies for a new organization. All right, these are the reg knowledge base that we used. Okay, it has your leave policy, your work from home policy, your performance reviews, your expense policies, etc. All right, once created, we loaded it with LangChain, then split it into different chunks. We provided the number of characters we wanted in each chunk. Okay, what should be the overlap, etc. Then we evaluated our chunks, inspected how they are looking, what is overlap, and how much overlap is there. Okay, this is what we did yesterday. All right, so today we'll continue from there. All right, so loading and all we'll again have to do because we are starting again. All right, but because we already had it in the previous session, we are going to use the same document, which is company handbook text, which you can see here. Okay, all right, so first thing first, load our environments. All right, can someone remind me which one did we use? Did we use LangChain community document loader or LangChain core document loader? Okay, we did use community document loader as text loader. Okay, and then we had to look for how to split our text into different chunks. So for that we use LangChain text splitter and we used character text splitter. There is also recursive text splitter, but we didn't needed that much of intelligence. So character text splitter does the job for us. Next is we have to load our environment. Okay. Can anyone just remind me once why do we use load .env? We have used it multiple times. I'll wait for you to confirm. Need at least one answer because this we have done so many times.
To
So
load the
this,
.env file here.
Yes, the environment file that we have, right?
yeah,
So our environment file can only be read when we use load env. And what does it contain? It contains our LLM, its API key. Okay. Only using that API key, you would be able to make that call. Okay, do not forget these things. See, no matter how many classes you attend, right? If you do not practice, if you do not go through the topics again, it won't be of much help, right? So that's the reason I'm repeatedly discussing those things so that you will always remember. Okay, but do some hands-on. Okay. Okay, so next is first we have to load the same company handbook text that we did yesterday. All right, we have to make sure that this part is run. We have already ran it. Okay, and hence it would be there for us to load this time. If you don't run it, the first part, the second part won't work because we are using the company handbook.txt. Okay, all right, splitter, we are going to use same character text splitter, chunk size of 500 and chunk overlap of 100. Okay, we yesterday tried with I think 200 as well, right? Just to show in better, how does the overlap actually look. All right, next is chunk. Now this is going to split your documents. Okay, in what size? In chunk sizes of 500 characters and chunk overlap of 100. Okay, now can one person remind me what do we mean by chunk overlap?
it will provide you the context, like if we are resuming something next. Yesterday you gave an example of preview in, like we are watching series, so from when we watch a new episode, so it shows some preview, so like that it shows some context related to that particular response or data.
Okay, thank you for remembering it. And again, thanks to Saurabh, the other Saurabh in this group. He was the one who came up with that example and a good one that could stick with people, right? The other example which I gave was suppose if you have a book and you tore some pages, right? Wherever the first, last sentence of one page is ending and the first sentence of the next one is starting, you would lose the context in between, right? So instead, if you have that context that the ending of one chunk becomes the starting point or the beginning of the other chunk, the context still remains intact. Okay, but good, thank you for remembering. Okay. Okay, now let's just print the length of the chunk and some gap. Okay, let's check if it is loaded or not. Okay, yes. So the company handbook.txt is loaded. Okay, just for the person who was not in yesterday, I'll just copy paste the same sample text so that they know what is that company handbook. So if we discuss some questions in between on that, you would remember. Okay, I'm hoping everyone has access to Teams chat now. Okay, I've pasted it. You can all see it. Okay, and so how many chunks are created? Five. All right. If you remember from yesterday, the chunk size was something around 1800 or something, right? So from that, considering the overlap, we created five chunks. Okay. Now the chunks are created. Next thing is embed those chunks and store in ChromaDB. Okay. So if we are going to put anything in, or anything that is going to interact with our environment variables, right? We have to interact with our operating system. For that, we import OS. Okay. Now, another one is if we have to do any changes in our folder structure, etc., we have to use the shutl. Okay. All right. And then Hugging Face embeddings, because we are going to use the embeddings or models from the Hugging Face. All right. Now, Chroma is again a library provided to us by LangChain for using ChromaDB. Okay, and all its functions are there that we can use for us. All right. Now, if for those people who are not able to download sentence transformers, for those sentence transformers would give an error. I'm just pasting it. It might be helpful for all of you. If sentence transformer doesn't install or didn't install, you can use OpenAI embeddings. Again, it will cost you a little, but at least in the class you will not fall behind. Okay. Just confirm if everyone is able to access Teams chat, right?
I can access now.
All right. Okay. Now we have to call for our embeddings. Which models are we going to use for embeddings? So we are using Hugging Face embeddings model, all mini LM L6V2. Now remember from our PPT, whatever you're using for vectorization, use the same model for querying. Okay. Because the mathematical representation created by this model would be different if you use another model. Okay. So we are using ChromaDB. Okay. Now, why do we have to give its path? Anyone would like to volunteer and try to explain? Because with this time we are going to save it in our disk. Okay. So we want to put it in a folder. All right. Hence, when we give a DB path for our directory for this DB, right? This will going to create a folder, and this is going to keep our database there, so that again you can use it the next time. Someone is there's some noise coming. Yeah, okay, thank you very much. Okay, all right. So we got our ChromaDB some disk space so that it can use it. All right. Now we are going to check if that path exists. If not, then we have to do what? If the path doesn't exist, what we'll do?
You have to create it.
Yeah. And if there is something that is already there and incorrect, then we can remove it and keep it. Okay. All right. So it works like this. You can use the same code again and again. All right. Okay. So this is going to first check if the path exists. Okay. Now tell me, what does RM tree does? Subtle RM tree. Yesterday I explained you, if you want to check what something does, what variables are there, what is the function description, you can do what?
Hover over the function.
Yes. Or there is one more thing that you can do. If you want to see what other parameters are there, you can do control space. Go there and do control space. Okay. All right. So here we are just checking if the path exists. If not, we are having it. All right. Now we are going to give vector store. What is vector store does? So vector store is going to create the variable that is going to hold our database. And using this variable, we are going to search or query the database for relevant chunks. Okay, just a mechanism for us to be able to search for our chunks within the DB. Okay, so vector store, yeah, vector store equals to chroma dot from document. This is correct. Okay, so documents that we are using are all chunks that we have created already. Okay, now for embeddings, we have already created the embeddings here. All right, so we are going to use the same. Okay, and this time, if you remember the last time we created, we didn't have to create a persist directory. We just created a client and we didn't create a separate vector store. We just started using it. Okay, this was from week 7's last class, right? But this time we are creating a persist directory that is going to create something on our disk so that the information would remain. Okay. Now let's check. Have the chunks been embedded? Vector store if the collection count, and collections, if you remember, is nothing but the collection of our chunks or the documents that we have put in our DB. Okay. So let's just check if it's been done correctly and are we able to load it. Okay. So we got that chunks embedded and stored in ChromaDB in total number of 5. So all the 5 chunks are being converted into vectors and put in our ChromaDB. All right. So everything worked here. We have our chunks stored. All right. Now what is next? We should check, are we able to search for those chunks or not, right? So let's look at one question. Let's look at our text first. Okay. And we'll find some relevant question. Okay. Let's look at the leave policy. We have 10 days per year in our sick leave. Okay, so let's ask for this. Okay, so how many sick leaves do we get every year? We are going to use vector stores. So basically this is again just a variable for chroma, right? So LangChain provides you with the similarity search. Similarity search is nothing but semantic search. Okay, question is your query and k equal to 3. What, just by intuition, can anyone tell me what would k equal to 3 mean?
Number of responses.
Can you be a little louder, please? I didn't get it.
Number of responses.
Yeah, so number of
Yes.
responses and number of relevant chunks, right? So if I put k equals to 3, right, when it is going to do the similarity search, it will look for the least distant 3 chunks. Okay, so first one would be the closest, the second one would be the second closest, third one would be the third closest, and it is going to search for all 3. Okay, okay, yeah, print your question. Okay, print, and just for extra space. Okay, if I do this, all right, right now, what is going to happen is we are just going to get the question. Okay, but what we want is we want the result and displayed in a manner, because the chunks would be very large. If you see it right now, let's look at it. Okay, we get 500 into 3 text this time. So you got the length of the chunks, but we want the chunks retrieved. Okay, so the same query that we used last time, but just difference would be we are going to use page content this time, which is again something provided by LangChain. Okay, for I in range, we are not using enumerate, just for simply for simplifying it. Not this, I don't want this. Okay, so we are first going to preview. This is a pretty similar thing that we did in the last one as well, when we did for preview, so that we get the result only up to an extent, so that we can see what is there in the either the first part of it or the last part of it, and that we were doing through slicing. Okay, page content. Okay, and instead of, because we just have 500, so let's do only 100. This is for new line. Wherever it will find new line, it will replace it with spaces, and that's how it is going to show it to us when we are previewing it. Okay, then if you remember, we did one more thing when we previewed it last time. Did you remember we removed the extra spaces?
Yes.
Yes,
Which,
Saurabh.
okay, and which function did we use for it? Okay, all right. So we used strip the last time, and we are going to use the same. Now, in fact, we don't even need to do this. Okay, this is again just going to print it for us in a manner which we can understand. Otherwise, the index would start from 0. It is just going to add 1 to it. If you don't put plus I, you'll still get the result. You'll just see 0, 1, 2 in the beginning. That's it. So that it will say chunk 0 instead of chunk 1 in the first attempt, and you are going to see all 3 chunks. Okay, okay, so let me just extend it. Okay, so chunk 1 preview. Namaste Foods employee handbook leave policy. All full-time employees get the following. Second, earned leaves, and third chunk is work from home policy, because that would, this chunk would be continuing from the previous one. Okay, So this was our question. How many sick leaves do we get per year? Okay. Was it able to go to the right chunk in the first go?
No.
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 No. No, we are not printing the complete chunk. This is just a preview of how many?
100 chunks.
100, right? 100 characters, right? We have 500 characters in this chunk. So if you see, I'm pretty sure it has printed the right one. Let's look at the actual chunk, right? And now, sorry, now the output that it has given. All right. The first one. So this is the first chunk. It has the leave policy. All right. So we were talking about leave policy. It would be coming, the first 100 chunk came up to following. All right. Till here. All right. I am pretty sure if you calculate, if this is 100 from here to here, okay, the next 100 would be from some here to maybe here. The next 100 would be somewhere here, the next 100 and so on, right? And it would continue till here. Okay, the next chunk is starting from earned leave. So basically, the first chunk was this long. Now, can you tell me, did it reach to the right chunk or not? We asked for sick leave. Our question, what is the question? The question is how many sick leaves do we get per year? Do you think this is not getting answered here?
Yeah, it is good.
Right, so it reached to
Yes.
the right one. Okay, just give me 1 second. There's an important call coming. Just hello. Am I audible?
Yes, sir.
Yes, sir.
Okay. All right. Sorry for that interruption. All right. So we could see that we were able to get the right chunk. Okay. The answer that we got was the right one. And the next most relevant chunk was again talking about leaves, and it would have gone to there. All right. Okay. So we saw that we can search in the chunks and it is able to retrieve good results. Okay. Next, we are going to pass the chunks to the LLM. Okay, and we are going to use OpenAI for that, and which is going to create a new call for our uh, our API call with OpenAI. All right. So for the same chat OpenAI, we used it if you remember in the LangChain class as well. Or dot. Okay, so dot prompts provide you with the option to prompt your model, but import language could not be resolved by lens. So has this been changed? Okay, let me see. LangChain clone OpenAI. Okay, yes. So it lies in LangChain underscore OpenAI. Okay. Prompt chat prompt template. So this is again the prompt templates that we created earlier. We can create with chat prompt template within LangChain. Okay. And lastly, to parse an output, if you remember, we used output parser, or maybe you all forget. Does it now remind something? We used output parser earlier, not on previous class, but I think
Yes.
2 or 3 classes back.
Yes, sir.
Okay. Okay. All right. Now, one more thing, right? Any of you who is facing an issue with, first of all, with OpenAI APIs, like I'm pretty sure the initial load that you would have done of say $3 or $5, whatever it was, that would still be there, right? You wouldn't have to recharge it, hopefully.
Sort of this one second. ChromaDB also needs some explicit installation or setup because I was getting some errors for that when I was
Pip
trying.
install, pip install.
Okay, yeah, okay, fine.
Okay.
Yeah, thanks.
Okay. All right. No worries. So again, the files that I provide you with, right? The extra file that are there in Google Drive, they all have those sections. If you don't have a library, those would be commented sections with pip install. You can just uncomment and run those.
Yes,
Okay.
yes, I was just trying parallelly with your yesterday's
Uh,
lectures.
we-
Sort of.
Okay, okay, okay. Which
Yeah.
is very good.
Okay.
Okay, but you can pip install, and I'm assuming that would still be ChromaDB. Okay. Okay. So we did this. Now, why I was asking about OpenAI, if any one of you are feeling that the cost is too much, or I just want to save on the cost side, you can use Grok, right? The Grok's API, though the output might be little different, right? But still, for learning purposes, you can still do it, right? What you just need to do is whenever you're calling or making an API call in an environment file with OpenAI, the next line add to Grok's API call, and you change your line with this. Okay, just to swap with Grok, you can do this. Okay, but yeah, I'm pretty sure for most of you at least, this, you didn't have to recharge it once you did. So after that, you didn't have to, hopefully. If that is the case, then you can start using Grok.
Sir, just one more question.
Yes.
How about using Olama for practice purpose? We can, as a SLM, we can
Sure.
download it. Okay.
You can definitely use that, no issues at all. The only thing is, know that if you're using any on-prem model and not with, directly with Hugging Face or anything, on-prem models would require your own infrastructure. That means your own CPU and all. So if you
Sure.
have good PC, please, go ahead with even larger models if you want. We have to do chat. What was the chat prompt template? This one, right? So let's directly pick it. Okay. Now, from messages, this will give you all the messages that we have to store. So last time as we did, okay. Now our messages, first give it our system message. So we want to use a simpler one. So answer the question something like this. Question using only context below. Not in the context, say I don't say sorry, just say I don't know or I don't have the information would be even better. Okay, so this would make sure that it uses your own context rather than, the LLM's own knowledge. Okay, so now we'll go and give it the context. Give this. We didn't have to do this. It will keep prompting you until you make a mistake. All right, so I'll just, system is here, this is here. Okay, now I'm going to give the context, and my context is what form? Human form, right? So let me rewrite it from here. Okay, so this is the information that we provided it. Okay, now we can give context here as well. That one, while copying, I was making mistake. Context and that. Just give me 1 second. Just 1 second. I'm not turning it off. Sorry, I was getting continuous noise. Hence, I was getting distracted. Okay. All right. Let me now rewrite it again. Okay. So we are giving the context to it. Okay, and the context is needed so that it knows that it only has to provide everything from the chunks that we are going to provide it. Okay, and then to context. Okay, there is one way with you can do which we did the last time, right? We actually explained it, what is the human context and how to provide it, right? The other way is you can directly give the context within the system instruction itself, right? How we can do it is you can, just like we do at the beginning, right? If you see, as we do in doc strings, right? Just like doc string, you can keep everything within it, all right? And then give little extra context like this, okay, if you want. And if you come here, right? So this way, what you are doing is you're giving everything within the system context itself. Okay, both the ways are right. You can do either way. This way, it all goes within the system context. Okay. All right. Next is we have to create a chain for lang chain. Can someone remind me how do we create that lang chain that we create with lang chain?
We have to define model parser and then
Yeah, and we made a small mistake. We didn't actually provide the model yet, right? So let's rename it to rag prompt. Okay, and LLM we can define here which LLM we are going to use. Okay, chat. So I don't want to use this. I think 4.1 is still good for me. Okay, all right. So here we now get in our prompt, in our chain. Now we can have our rag prompt, right, which is going to be our prompt. Then we have to explain which LLM to use, right? So, and our output parser, because we need to make sure that the output that comes is in a manner that we can use it. All right. So this is the chain that we have created. Now calling through that chain, let's use chunk text. So in chunk text, what we are doing is we can do it like this as we did in the previous one, right? We used list comprehension, but to explain it simply, you can consider it, an empty list for now, and then you can run the for loop outside. Okay, it will loop through the complete length of the results Okay, then chunk text dot append results I page content. It will keep appending the result with the index that the value would be moving. Okay, then we are going to join the chunk. Whatever text is generated, we'll just for visualization. Now, do we run with chain dot run or chain dot invoke? Anyone remember we use chain dot invoke somewhere?
Invoke.
Okay, so two things we had to provide. We did provide the context and we provide the question. Okay, now we can simply print it. So I first want to print the question. Okay, and then want to print the answer. So let's see. Hopefully it should work. I don't have answer the question using I don't have no, I don't have to use messages equals to here information that context because we have one quote, three quotes, three quotes, and then human question, one quote. Yeah, this is correct. So fourth one is pass chunks to LLM. We would have passed the chunks to LLM now. These are chunks that are there. We are now passing them to the LLM. And let's see, has it been able to answer? It says you get 10 sick leaves per year. Is it correct? Let's
Yes, sir.
yes, you get 10 days of leaves per year. And this context we have provided it to the LLM with our prompt itself. All right. So it is taking the right chunk size. All right. So this is the actual RAG implementation that we have just seen, but on a smaller scale. All right. Now, one thing, what do you think would happen if we are going to give it something from outside? Okay. For an example, let's say any edge case. Okay, so print. Okay, and then one more just all right. Now let's ask a edge question. Okay, whoever is from testing background would be able to understand it a little better. So what all we covered? We covered leave policy, work from home policy, performance reviews, expense policy. Okay, nothing on salary or ESOP. Sorry. Okay, now if I'm going to ask it a question that is out, from outside its context, all right, what would happen? What should happen ideally?
It should say no, as you have handled it as a safety net.
It should say that I don't have this
Yeah.
information. Ideally, we are doing the same thing that we did on top again. Okay, so nothing crazy here. Question and print the answer. One gap, please, for better. And if it gives the answer that we are expecting, that would mean the use case for RAG is successfully implemented. And that is the reason why we use RAG, so that we get correct information and only that information if it is with us. If it is not, the LLM shouldn't answer or give hallucinated answers. See, it gave us, I don't have the information. Okay. Suppose if in your application that you create for anything, for an external user, right, which is going to interact with your application, if they put anything outside of that context, ideally you should not answer, right? If it would start answering, then your application is failing. So that is why RAG is used at a lot of places. Okay, so this was a small implementation of RAG.